Welcome back to another day in chemistry. Okay, today we're talking about our conductivity and covalent ionic compounds. This is the lab you need to have pulled up. Go find it now. It'll be linked in the comments in the description box below. All right, pause the video, and I need you to read these two paragraphs and circle any important words. I'm going to dramatically stand here so you can pause the video. Awesome, good job. Let's think about some words that we circled here. Important words like, good job, ions. Yep, that was a good one. What's another one? Oh, yep, electricity. That's good. Oh, covalent. Yes, good. Oh, ionic. Oh, good. Oh, you are so good. Valent. Yes, this is what virtual school felt like. Conduct. Yep. Good job. Okay, so after reading this, we can deduct and summarize this in a simple chart. Ionic compounds conduct electricity, and covalent compounds do not. All right, but the real question is, do you know what you're drinking? Do you know what you're eating? For example, a lot of people think Gatorade has electrolytes in it, and therefore we would assume that it lights up. Well, let's find out if that's true. Here's a pre-lab discussion. 4 questions here. Pause the video. Answer those. Don't actually literally pause. Did you literally pause it? You almost did. You were like real close on these. Okay. You fought the urge. I'm proud of you. All right. So the problem of the day is, how can the conductivity of a solution help you classify the bonds in the solute? That's what we're going to do. Safety. Got my goggles on. Let's go over and complete this. Wow. Transition. Perfect. Welcome to the lab. Go ahead. We're going to work right here, guys. The first solution we're going to test should be mouthwash, but guess what I don't have? Mouthwash. So instead of mouthwash, we're going to do Powerade. Yep. And it's going to magically appear. Ding. Okay. This right here is called a conductivity probe, meaning it establishes whether or not something is conductive, or if there's electricity flowing through it, or ions flowing through it. All right. We're going to be safe today and make sure that we take our time. Let's see if the light bulb lights. Whoa! Wow! Whoa! So would we analyze this as poor, fair, or good? I would say that this is a good conductor. Whoa! So in your chart, we're going to put good in that first box. Let's do the next one. The next one on the list is Alka-Seltzer in water. But first, we're going to clean off our probe. Notice I turned it off so that I don't shock myself. Again. All right, here we go. Alka-Seltzer in water. Thank you, magic helper. Whoa! It's lit. You know what this would be cooler with? If the lights were off. Ding! Whoa! It's lit! Wow, that's exciting. That was Alka-Seltzer in water. Next, we're going to test ammonia in water. Ammonia is found in a lot of things. Ammonia can kill you. So don't, drink it. Let's do it. Ammonia in water. Whoa! That one's good too! It's lit! Next up, we have baking soda in water. Let's check out baking soda in water. Notice I'm cleaning off the probe to prevent double contamination, cross-contamination. Stanley, that's a smart idea. Thank you. Here's baking soda in water. Pause. Do you know what this instrument is? It's called a pipette. Shoot. I am so glad that I used a school-appropriate word in that moment, because we would have had to start over. This is definitely a good conductor. Look how bright that light is. Wow, this is baking soda and water. Did you know that you can use baking soda to kill fleas in your house? Because your dog was around other dogs and got fleas in the wintertime. Next, we have Coca-Cola. Coca-Cola is so strong that it can degrade ground beef and human flesh. But it's a fair conductor. I would have thought it would have been a strong conductor because it's so strong, but it's not. Shocked me.
We don't got coffee.
We do not have coffee. That is correct. Because coffee smells like poop. So we're going to skip coffee and go to the next one. Let's try lemon juice. Lemon juice seems like it definitely should light, right? I would say it would light. Let's see if that's the truth. Ooh, actually, I don't know what we did earlier. It lit. I would give this a good level of electricity, of conductivity. All right, next up, shocking some people over here. Don't know about you guys. Let's clean this up a little bit. Probably need to use some deionized water to clean these probes off. It's okay for today. What's next? Milk. This milk has been through a lot. But it is a fair conductor, which is shocking me. All right. Oh, that's very tasty. Yum. Next, we have grapefruit juice. I think I need to clean off these probes. Next, we have grapefruit juice. Thank you. Grapefruit juice is pretty poor, but it's actually lighting, so we got to give it a fair. This would be fair. Fair. Next we have, oh, it smells bad. Next we have Gatorade. Oh my goodness. Yeah. Got it. Thank you. Next we have Gatorade. Yeah. Whew. That ammonia is smelling. Next we have Gatorade. Gatorade has electrolytes in it, so let's see if it lights. We're almost done, kiddos. Ooh, I would give it fair. I would say this is fair. All right, let's look at cranberry juice. We do not have cranberry juice, so we're gonna go to the next one. We're gonna go to sugar water. Sugar water. Thank you. Sugar water. Thank goodness. This is poor. Poor. Because it's not lighting at all. Poor. Poor conductor of electricity. Alright, next we have tea. Actually, we don't have tea, so we're going to go to tomato sauce. Yummy in my tummy. Tomato sauce. Is tomato a fruit or a vegetable? Jeez. This is good. Next up, we're going to have vinegar. 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 Guess what? She's not on. Fair. Fair. All right, last but not least, just kidding, we have powdered hand soap in water. Powdered hand soap in water. Do I have the bleach up here? Yeah, I do. Yeah, I do. Powdered hand soap in water. Thank you. Ooh, this is good. Good. Next, we're gonna have bleach. 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 Jeez. This is good. Good. All right, and last but not least, we have drain cleaner. There's a lot of drain cleaner on the floor. Did you know that the drains in the school? Drain cleaner didn't even help. Fun fact. See what happens. What do you think? Is it gonna light? It lit. All right, guys, let's turn the light on real quick and let's analyze what we just saw. Turn the light on real quick. Turn the light on real quick. Turn the light on. Okay, back to the board, friends. All right, so we have talked about the difference in conductivity, but our next column says type of bonds. Here are our options. We have nonpolar, polar, and ionic. All right, so let's talk about what this could possibly mean. All right, when I think of the word polar, I think North Pole, South Pole. There's a North Pole and there's a South Pole, and it has to do with the magnetic tilt, okay? Magnets have a positive end and a negative end, which is true of our compounds as well. So if something is nonpolar, that means that there isn't a distinguishable positive side, there isn't a distinguishable negative side to it. But polar, it means that there is a slightly more negative and a slightly more positive side to our molecule. They'll share and pull electrons in different ways, okay? Ionic, we know that a cation is positive and an anion is negative. So knowing this information, let's use our three categories for our results, our conductivity, to figure out who goes with what. So our first category was poor. We had fair, and we had good. Well, we know from our paragraph earlier that ionic compounds are good conductors of electricity, so we know ionic is going to be good. Now, polar has a slightly positive and a slightly negative, so that would create fair electricity, conductivity. Nonpolar, of course, is going to be poor because there's no positive and there's no negative branch. So, as far as type of compound, we're going to skip that column because, to be honest, I have no clue what they're talking about in that column. I'm very confused. It could just be covalent versus ionic, but we already discussed that. So this is what I need from you guys. I need you to answer these three analysis questions using the information that we just talked about. Pause and rewind if you need to. Other than that, get this turned in because guess what? This is a summited. Yay you. All right, well, thanks for coming to chemistry with Miss Stanley.